I want to make this quick video to help you all with the section on the Delta Math where you had to write the function. So when you're writing the function for the piecewise, you're creating basically equations for each of these parts, right? So you have this first one here on the left has a y-intercept of -4. To write the equation of the line, I also need to figure out the slope. So from this y-intercept, if I go down 1, right 1, that means I have a slope of -1. So what I'm going to do is I'm going to say the equation for this is -1x, right? Remember, y equals mx plus b is for the typical way we want to write the equation here. All right, so -1x, and then our y-intercept is -4, so -4. And then from here, I need to state what the domain is. Well, this graph only exists starting at x equals 1, and then everything to the left of it. So I'm going to say this exists for when x is less than or equal to +1. That's the domain. Now for this next one, there's two ways I can try to figure this one out. So this one, I don't see where it crosses the y-axis, right? So I could try to guess and figure out where it might be by using the slope. So here, if I go from this open dot, if I go up 2/1, that's the slope. So if I go down 2, back 1, down 2, back 1, down 2, back 1, down 2, back 1, and then down 2, back 1 again. So I'm kind of like down here. That's going to be our y-intercept, right? So I can try to figure this out by saying, all right, down 2/1. So I need to do this 1, 2, 3, 4, 5 times to get to the y-axis. So if I go down 2/1 5 times, I'm going to be going down 2 5 times. So 1, 2, 3, 4, 5. All right, and then I'm here. So I can take this y value, -9, and say if I go down 5, or sorry, go down 2 5 times, that's a total of 10. That's going to put me at -19. So then what I could do is I could say, all right, the equation for this is our slope is 2, because we're going up 2/1. And then our y-intercept would be at -19, right? And then I could say for the domain of x has to be greater than 5, but not including 5 because it's an open circle, right? So this is one way I could do this. Now, the other way, I'm going to see if I can write up here on the screen here. So the other way that I could do this is I could use this point and treat this as a sort of a transformation. So this point is located at x equals +5 and y equals -9. So if I think of it as a transformation, this would be right, and then this would be down. Oh, I did not mean to zoom in. And then down. All right. So then from here, I could say, since this is right and then down, the equation for this line would be y equals 2. And then I want to shift this line, the normal line, to this point. So right 5 and then down 9, right, using transformations. Remember, right and left have to be inside the parentheses, and then up and down have to be on the outside of the parentheses. Now, if you're wondering, like, how is this the same as what we have there? There we go. I don't know what happened there. And so what I could do then is I could say, well, this does match this 2x minus 19. If I distribute, that gives us 2x minus 10. Bring down the -9. and then this becomes 2x minus 19, right? So it's the same, it's going to end up being the same equation for the line. They just look different, okay? And so I can use this method here to write the equation of the line, okay? Now, obviously for this, I don't necessarily need to because I figured out that the y-intercept was negative 19, right? And so now that I have it, I should be good to go here. And exit the draw. Okay, so then I can submit, right, and go to work. Okay, now, so if I'm looking at this one, so this is just another example. So I'm looking at this, I'm like, all right, well, this one, right, doesn't touch the y-axis, but I know it'll touch down here. I could, again, work backwards to figure it out. But what I can quickly do is say, all right, well, what is our slope for this line? And when you're finding the slope, be careful when you're going backwards. This is up 2 and then back 1, which means if you think rise over run, up 2 is positive, back 1 is negative. So our slope here is -2. And then I can use this point as a trick from the last one, is to say, okay, this point is located at -4, -2. So if we think about the direction that would be left 4 and down 2. So I can write it like this, and then think about how left has to look, right? Left 4, down 2, right? And then the domain is still going to be the same. So the domain for this would just be basically anything less than -4, but not including -4. This other one is just constant, so whatever the y value is for that is constant there. And it only exists when x is greater than +4, right? And if I did that correctly, this whole left 4 down 2 because of this point, then I should be able to get this right. I did. All right. So I think that hopefully helps. You can do that at any point in time. If you know your slope, so like this one will be up 1 over 1, 2, 3, 4. So up 1 over 4. I see the point here is left 4 down 2 again. Left 4 down 2. And then our domain, right? Now this one up here though, I see the y-intercept is 3. So then our slope is up 2 over 1. So we have a slope of 2x, or 2. So the equation would be 2x, and then since our y-intercept is at 3, we would say +3. And then you would just state your domains for each of these sections. This one here is less than or equal to -4 for the domain, x value here, and then the x value here is -1, so x is going to be greater than that, not including -1. And then if I submit, I should be good. Okay, so hopefully this helps. All right, thank you.